Hello and welcome to the Sleepy Narrator. I'm so glad you've joined me tonight. Perhaps you're curled up beneath soft blankets, ready to let go of the day, or maybe you're slowly unwinding, letting your thoughts quiet. Wherever you are and however you're listening, this space was created just for you, to slow things down, settle your mind, and gently explore the universe's quiet wonders. Before we dive in, please share. Where are you listening from and what time is it there? Drop it in the comments. It's always heartwarming to see where our sleepy little science crew is joining us from around the world. Now we'll go to the story of the speed of light, a tale wrapped in stillness and motion, filled with satellites that float and signals we never see. It's the story of how we know where we are and how the cosmos quietly keeps track of time. But don't worry, we're not jumping straight into equations or flashing constellations. Instead, we'll begin with silence, with a sensation you've always felt but perhaps never fully noticed. So let's lie back for a moment, breathing softly, letting calm gather around us like mist across a sleepy field. Because even as you lie perfectly still, warm and safe, your body is moving, not in a poetic sense but in reality, and at a speed that's truly astonishing. Right now, your body is rotating with the Earth, over 1,000 kilometers per hour if you're near the equator, swifter than a passenger plane. And that's only part of it. The Earth is also orbiting the Sun, gliding through space at nearly 30 kilometers per second. That's around 67,000 miles per hour just to stay in orbit with the star that warms your skin each day. And beyond that, the entire solar system, sun, planets, moons, and dust, is drifting in a massive spiral around the center of the Milky Way galaxy at over 800,000 kilometers an hour. You feel still, but you are soaring. You don't feel it, of course. There's no breeze brushing your face, no dizzying sense of motion in your stomach. But deep inside your cells, every particle is part of this silent voyage. Motion isn't always felt. It's often the calm undercurrent holding everything in place. Think of it like gliding on a smooth, silent train. Without a window, you'd never realize you were moving at all. This is the nature of motion in the cosmos, relative, subtle, and constant. There is no fixed center in the universe, no absolute reference point where all else is measured. Everything moves in relation to something else. You're still in your room because you're motionless compared to your pillow, the walls, the ceiling. But to a comet streaking past, or a distant moon, or even the orbit of Saturn, you're part of a never-ending motion. Stillness, then, is just a matter of viewpoint. Picture yourself floating above the Earth. Not in a satellite, at least not yet, but somewhere higher, high enough to see the planet curve. You'd watch the ground turning slowly below, oceans shifting, cities waking and fading. You'd see that your resting body is joined in a much bigger movement. Every breath you take is part of a world spinning, orbiting, and drifting through space. You are a traveler in an ancient rhythm, a cosmic dance of gravity and motion too immense to feel. And yet, this motion makes life as we know it possible. The rotation of Earth brings day and night. Its orbit creates the seasons, warmth, and growth. Even the solar system's journey through the galaxy nudges gas clouds together, forming stars, fresh light in the darkness. So motion is not the opposite of peace. It's the hidden stage where life unfolds. Now return gently to your breath. Feel the air as it enters and leaves your body. That quiet pattern is your personal orbit, a rhythm that sustains you, just as planets follow their own celestial paths. Your body lives in cycles, your pulse, your thoughts, your sleep. And far above, something remarkable is happening. High in the sky, too far to see and too fast to notice, satellites pass overhead. They move faster than bullets, tracing silent trails around Earth. Their paths are not upward or downward, but always around, falling forever, yet never hitting the ground. Though distant and voiceless, these satellites know exactly where you are. Not just your town, not just your street, but the precise point where you're lying now, often within a few feet. And they do it not with eyes or maps, but with time. They find where you are by knowing when you are. And this is where our story gets even more fascinating. Because time, like motion, isn't always what we think it is. Up in those high orbits, time ticks a little faster. Not dramatically, not in leaps, but just enough to matter billions of a second faster. Meanwhile, down near Earth's surface, time ticks just a bit slower. It's not something you'd feel, but it makes a difference. Without correcting for this, your GPS would be wildly inaccurate, off by miles each day. Why? Because the very fabric of space and time bends under gravity and speed. And now, we begin stepping into the world of relativity, Einstein's gentle revelation, the invisible rules that satellites must follow to help you find your way home. We'll dive into that soon. But for now, just know this: even when you think you're still, you're part of something ancient in motion, older than the oceans, older than light. Motion, elegant, quiet, persistent, is what ties your tiny moment here to the stars. As you relax more deeply, remember this never stops, even in silence, even in sleep. High above you in the blackness of night, a beam of light begins its journey toward you. Light begins in quiet. It flickers into being at the heart of a star, or from the vibration of an atom or the flick of a tiny switch. Then it moves, without delay, without wait, always at the same speed, always straight ahead. Tonight, while you lie completely still, something ancient and steady drifts through your world, brushing past your pillow, filtering through your curtains, gently touching your skin. Light. Even in this dim room, light is never far. Some comes from the moon, sunlight bounced off a cratered surface. Some arrives from stars, exhausted travelers that spent years crossing space just to land softly on your wall. And some is made by us, tiny flickers from screens and lamps, quiet companions through the dark. But what is light really? Light is more than brightness. It's a messenger. It brings stories of where it came from, of what it passed, of what it touched. It doesn't use words, it speaks in waves. Each wave of light moves with precision, like ripples spreading across a calm pond. But it moves faster than anything else can. It never slows down. It never hurries. It is always itself, racing at nearly 300,000 kilometers per second. The fastest anything can go. And yet, when you see it, it doesn't feel fast. It feels gentle, immediate, sometimes invisible. Light gives you color, sight, warmth, and rhythm. It tells you where you are. It lets the earth whisper to the sky. Now imagine a beam of light leaving the sun. It doesn't meander. It travels in a line unless something curves it. A drop of water, a pane of glass, the pull of gravity. It moves past clouds, through air, past dust and satellites, and eventually finds your face. That one beam, it's 8 minutes old when it gets to you, older than your last thought. Born in fusion, pushed through 1,000,000 kilometers of burning plasma. It travels just to bounce off your book or shine into your eyes. And when it reaches you, your mind reads it, interprets it, understands it. You don't see a tree because it shines. You see it because it reflects. Leaves bounce back the light they don't need, mostly green. What they keep is red and blue, the energy they use to grow. So in a way, you're always seeing what the world lets go of. Light reveals what things are, and sometimes what they're not. Let's pause to consider something. You don't truly see with your eyes, not in the way we often think. What you actually see is light. Without light, vision simply doesn't occur. Your eyes aren't projecting, they're receiving. They detect light waves bouncing off the world around you. What we describe as seeing is really your mind interpreting reflections, assembling images from rays of light that have traveled, bent, and arrived with stories to tell. Picture yourself observing a distant mountain. That sight doesn't occur instantly. The light entering your eyes left that mountain a brief moment ago. And when you look up at the stars above, you're not seeing delayed light. You're gazing at the past. The light from those stars can take years, centuries, or even millennia to reach your vision. Some of them may no longer exist, yet their light is still arriving. The night sky becomes a window into history, and light is the messenger carrying the tales. And here's something even more extraordinary. Light travels swiftly, yet it doesn't experience time. For us, seconds flow forward steadily. But for a single photon, a particle of light, there's no passage of time at all. If a photon somehow had awareness, its entire voyage, from creation in a star to arrival in your eye, would feel instant. No journey, just a beginning and an end with nothing in between. This idea might feel hard to grasp, but that's the nature of light. It's like nothing else in existence. It doesn't carry mass, so it isn't slowed, weighed down, or aged. It simply travels, always at the same universal speed. Everything with mass, like people, planets, or spaceships, can never reach that pace. The nearer we get to it, the more energy we require and the more we seem to increase in mass. But light has no such limiters. It moves freely without effort. This matters deeply, because light is the only way we understand what's out of reach. We can't hold a galaxy in our hands. We can't reach out and touch the sun. But light comes to us. It brings their messages. The warmth you feel on your skin, the shimmer of stars, even ancient cosmic signals all arrive as light. And since it travels at a known fixed rate, we use it as a standard, a cosmic yardstick, a precise clock, a bridge between distance and time. It's not just that light is fast, it's that its speed never changes. It doesn't vary based on your movement or position. Whether you're still, racing through space, or floating far above Earth, light always moves at the same pace. And because of that, something else in the universe has to adjust. To keep light's speed unchanged, the universe bends space and alters time. This concept, introduced by Einstein, reshaped physics. Imagine yourself in a spaceship hurtling through space at incredible speed, near the speed of light. Inside, you shine a beam from one side of the ship to the other. The light crosses the room just as you'd expect. But someone observing from outside the ship would see a different picture. As the ship moves forward, the light travels not just across the room but also along with the motion. To the outsider, it follows a longer, angled path. Yet both you and the observer measure the beam's speed, and you both get the exact same value. How can that be? It only works if time slows down aboard the moving ship. That's called time dilation. It means time isn't fixed. It flows differently depending on speed and gravity. And it isn't just theory. We've observed it. Particles accelerated to near light speed decay more slowly. Astronauts aboard the International Space Station experience time just slightly slower than those on Earth. These changes are minute but measurable. Time, it turns out, is flexible. You likely won't notice time shifting as you go about your day. At normal speeds and gravity, the difference is tiny. But when we rely on extreme accuracy, like in satellite navigation, even these minuscule variations become crucial. Think about GPS satellites. They orbit the planet at high speed and are farther from Earth's gravitational pull. Time moves just a bit quicker for them than it does for us on the ground. If we didn't account for that discrepancy, GPS systems would become inaccurate, drifting by kilometers each day. To keep our technology precise, we must correct for these time shifts, applying Einstein's equations to the devices that help us navigate the world. It's a quiet, constant adjustment, ensuring your phone knows where you are. Let's go back again to that single beam of light leaving the sun. It begins in the sun's core, born from nuclear fusion. Atoms pressed so tightly together that they merge, releasing energy. That energy begins a slow journey, bouncing through the dense interior of the sun for thousands of years before it escapes into space. Once it reaches the surface, it travels freely, 8 minutes at full speed across the vacuum of space. It doesn't need a medium, a road, or a path. Light moves through emptiness effortlessly. When that beam reaches Earth, it may land on a blade of grass, warm your hand, or reflect into your eye. That's the end of its long journey. From fire to stillness. What's beautiful is that light doesn't hold back. It gives all its energy, its warmth, its information, its momentum without hesitation. It doesn't linger. It doesn't grow tired. It just travels and then vanishes. That's why light is so central to our understanding. We don't just see with it, we measure and communicate with it. Telescopes capture light to study stars. Microscopes use light to explore cells. Fiber optics pulse with light to send your voice or a message around the globe. In many ways, light connects every corner of the Earth and even connects us to the cosmos. But even beyond technology, light holds a kind of poetry. Because it moves at a constant speed, it defines what we can observe. The edge of the observable universe, the farthest distance we can see, is set by how far light has traveled since the beginning of time. Roughly 46 billion light years in every direction. That's the edge of our cosmic horizon. Beyond that, light hasn't reached us yet. Those places remain unknown, waiting for their light to arrive. So light draws the boundary between mystery and understanding. Now, consider how light affects you personally, not just your vision but your entire rhythm. The daily cycle of brightness and darkness shapes your sleep, your energy, your mood. Your body responds to light. It tunes itself to sunlight and nightfall. Even now, in this moment of stillness, your body is adjusting. The absence of bright light tells your mind to slow down. Your pupils widen. Your thoughts settle. You prepare for rest. And in this hush, light takes on a different tone. It's no longer about clarity or speed. It becomes intimate, gentle, present, even if you can't see it directly. Maybe there's a small lamp glowing nearby. Or perhaps your screen glows faintly. That's enough. You don't need bright light to feel connection. As the world softens, light becomes more like breath, constant but invisible. And in this space where thoughts drift and motion slows, light continues its journey. It crosses oceans and skies. It leaves distant stars and distant planets, traveling endlessly without weight, without rest. Even when your eyes close, light goes on. It moves in silence, bearing stories from places you may never see. It passes between atoms. It flows through time. It is always on its way, quiet, constant, and infinite. In this moment, as you sink into rest, light continues its ancient path. And somewhere in the far distance, a photon is just beginning its journey toward you. Let's drift now into something even more subtle, because light isn't only a beam or a wave. It's also a particle, something called a photon. And photons behave in a way that's unlike anything else we know. They don't follow the familiar paths of baseballs or sound waves. Instead, they exist in a strange, almost dreamlike way. Sometimes a photon seems to be a wave, stretching out across space, interfering with itself, creating patterns. At other times, it behaves like a tiny packet, a single bump of energy arriving all at once. What's more mysterious is that the way you observe it affects how it behaves. In certain experiments, simply choosing to measure a photon a particular way changes whether it appears as a wave or a particle. This isn't a trick or an illusion. It's built into the structure of reality. On the smallest scales, particles don't act like little solid dots. They exist in clouds of probability, fuzzy regions of what might be, only becoming definite when observed. This is part of quantum mechanics, a field of physics that often seems to blur into poetry. And yet, it's incredibly accurate. Every electronic device, every modern piece of technology relies on quantum principles. Even light itself, as ordinary as it seems, obeys these strange laws. Think of light traveling through a slit, a narrow opening. When many photons are sent one by one through the slit, they form a pattern as if they're waves interfering with each other. But they go through one at a time. How can they interfere if they're alone? It suggests that each photon, in a way, explores every possible path. It behaves like a wave until it's measured, and only then does it choose a position. This makes light feel like a whisper between possibilities, a murmur of what might be until certainty arrives. Now imagine a mirror. When light hits a mirror, it reflects. That's simple enough. But what's really happening? Photons are absorbed by the atoms in the mirror's surface and then re-emitted. The process is instant and silent. The direction they bounce depends on the angle they strike. It's predictable, yet underneath, it's built on chance. At the quantum level, even reflection involves a kind of decision, a choice made by the universe itself, guided by probability. And this is not just abstract theory. It affects how light moves through lenses, how it bends in water, how rainbows form. Every shimmer and sparkle is shaped by quantum rules. Let's go further. When light moves from one medium to another, say, from air into water, it slows down slightly. Not because the photons themselves are slower, but because they interact with atoms in the material. They're absorbed, then released, over and over. The net result is a reduced speed. That's why light bends when it enters water, a phenomenon called refraction. It's what makes your hand look bent if you dip it halfway into a pool. It's what creates the brilliance of diamonds and the shimmering of sunlight on the ocean's surface. But not all light is the same. Different colors of light have different wavelengths. Red is long and slow, blue is short and quick. And because of that, they bend differently. This is dispersion, the reason a prism splits white light into a rainbow. Each color takes a slightly different path, unfolding into a spectrum. White light is a blend of many waves, a harmony of frequencies. When it passes through glass or droplets, it separates into individual notes. This is how rainbows happen. Sunlight meets raindrops in the air. Light enters each droplet, bends, reflects inside, and exits. Along the way, it's split by color. Billions of these tiny droplets scatter the light, and to an observer at the right angle, a rainbow forms, a perfect arc of color hanging in the sky. It's geometry and physics, but also wonder. A rainbow is not located in a specific place. It depends on your viewpoint. Someone standing beside you sees a different rainbow. The arc is personal. It's always opposite the sun, always the same shape, always just out of reach. You can't walk to a rainbow. You can only look and let it come to you. And that, too, is part of light's quiet magic. It doesn't just show us the world. It creates the beauty we see in it. Let's return to light's speed for a moment. It moves at 300,000 kilometers per second in a vacuum. That's fast enough to circle the Earth more than 7 times in 1 second. And yet, in a sense, that speed is also a limit. Nothing can move faster, not even information. This becomes important when we think about distance. The farther away something is, the longer its light takes to reach us. We don't just see objects, we see the past. Light from the moon takes about 1¼ seconds to get here. From the sun, about 8 minutes. From the nearest star, over 4 years. And from distant galaxies, billions of years. We are always seeing history, never the present. Even your reflection in a mirror is slightly delayed, just a few nanoseconds. But it's not truly now. Light took time to travel from you to the mirror and back. This delay, though tiny, is real, and it's universal. So in every glance, in every view, you're looking into the past, however slight or distant. That's a beautiful thought. The entire cosmos is revealed not in real time, but as echoes of what once was. Telescopes are time machines. They capture light from long ago. The farther they peer, the older the image. Some show us galaxies as they were just a few 100 million years after the universe began. Those photons have traveled across unimaginable gulfs, untouched, uninterrupted, just to arrive in our detectors. The oldest light we can see is the cosmic microwave background, radiation from the Big Bang itself. It fills the sky, faint and cold, a whisper of the universe's first moments. And it too is light. Not the bright kind we see with our eyes, but stretched by time into microwaves. Ancient light, faded by distance, but still carrying the memory of creation. Light is the universe's storyteller. Now let's think about darkness. We often picture darkness as the absence of light, but in space it's more complex. There are places with no stars nearby, no planets, no reflected light, just blackness. Yet even there, photons move. Background radiation persists. Particles collide. Darkness isn't empty. It's filled with quiet activity, much of it invisible. And your eyes, when adjusted to the dark, can detect single photons. They are that sensitive. In total darkness, your body becomes a detector of the faintest signals. Even a candle seen from miles away can register on your retina. You are tuned to light, built to perceive it, shaped by it. From the first morning you ever saw to the screen glowing in front of you now, light has always been your guide. And light doesn't just show the outer world. It reveals the inner one too. When you dream, your mind can simulate light, creating images, scenes, places that don't exist. Your brain paints with memory and imagination, generating its own internal illumination. Even closed eyes can flicker with light. Pressure on your eyelids, electrical activity in the brain, these can produce sparks, flashes, phosphenes. Your vision is never truly blank, because light, whether real or imagined, is part of how you understand. Let's come back to a single candle in the dark. Its glow flickers, it warms the air, it casts a shadow. That light radiates outward in all directions. Photons fly away at light speed, carrying energy into the night. Some will strike a wall, some will pass through a window, some will travel for miles, and some may continue beyond Earth, beyond the solar system into interstellar space. That candlelight, gentle and ordinary, becomes part of the universe's light show, forever traveling, never tiring, and though it fades with distance, it never truly disappears. The universe holds on to every photon, absorbs it, re-emits it, transforms it. Nothing is wasted. Even the quietest light contributes to the story. So when you light a candle, or turn on a lamp, or simply lift your eyes to the stars, you're taking part in something ancient, something shared by galaxies, atoms, and everything between. Light is not just a feature of the world. It is the thread that connects all things, and it moves always forward, into time, into distance, into wonder. Let's now consider something not often realized. Light can be bent, not just by lenses or prisms, but by gravity itself. It sounds like science fiction, but it's deeply real. Massive objects like stars and galaxies warp the fabric of space around them. Imagine space as a soft sheet and a heavy ball placed in the center. The surface dips, curves. Now roll a marble nearby and it spirals inward. That's gravity, not as a force pulling, but as space itself being curved. And light, even though it has no mass, must follow the curves in space. So when light passes near something heavy, its path bends. This is called gravitational lensing. It means a star or galaxy behind a massive object might appear in the wrong place, or even appear multiple times in arcs or rings. Some of the most beautiful photos in astronomy show these effects, swirls and smears of light caused by gravity's warping hand. In fact, this bending of light was one of the first proofs of Einstein's theory of general relativity. During a solar eclipse in 1919, astronomers observed stars appearing slightly out of place because their light passed close to the sun and bent on its way to Earth. The sun had shifted the stars, not by moving them, but by altering the space through which their light traveled. Even now, we use gravitational lensing to study the invisible. Distant galaxies hidden behind others become visible, magnified by the natural lenses in space. Sometimes we even detect dark matter, stuff that doesn't emit or reflect light, by how it bends the light around it. Gravity becomes a tool to see the unseen. And this leads us to something even stranger: black holes. These are regions of space where gravity is so intense that not even light can escape. Anything that crosses the event horizon, the edge of the black hole, is lost from our view forever. It doesn't mean the object is destroyed instantly, but from the outside it's gone. The light it once gave off can no longer reach us. A black hole isn't a hole, not in the usual sense. It's a collapsed star or mass so dense it creates an infinite well in space. Not even light, with all its speed and freedom, can climb out. But that doesn't mean we can't study them. As matter spirals into a black hole, it heats up, glows brightly, and emits radiation. Some of the most energetic regions in the universe exist around black holes, not within them but at the edge. And recently, scientists captured an image of a black hole's shadow. Not the hole itself, but the glowing ring of gas and dust around it and the dark center where light vanishes. It was a triumph, a photograph of the unseeable. Again, light told the story. Even when it couldn't escape, its absence revealed a truth. Now let's drift to something quieter. When you look at a candle flame or sunlight through leaves or the shimmer on water, you're not just seeing light. You're seeing how your brain processes it. Your eyes detect photons, but your mind interprets them. It sharpens edges, fills in colors, enhances contrast. It's why you can find shapes in clouds or see faces in tree bark. Your brain seeks patterns. It also filters. You don't notice your nose, even though it's always in view. You stop seeing your glasses after a moment. You're constantly looking but rarely noticing everything. Light is everywhere, but attention decides what matters. This selective focus helps you survive. You don't need to see every blade of grass, just the movement of something unfamiliar. You don't need to notice every star, just the one that guides you, but it also means you miss things. Light carries information that gets filtered, ignored, or misunderstood. Consider a sunset. It's not just beautiful, it's a physics lesson. As the sun nears the horizon, its light passes through more atmosphere. Shorter blue wavelengths scatter away, leaving reds and oranges. The colors change not because the sun changes, but because the light's path changes. And yet, you don't think of scattering. You feel warmth, nostalgia, a sense of closure. That's light filtered through emotion. Or think of a thunderstorm. Lightning flashes, a sudden, raw burst of light. It travels faster than sound, so you see it before you hear thunder. That difference reveals distance. Count the seconds. Divide by 3. That's how many kilometers away it struck. Light becomes a measuring stick, a warning, a countdown. Even animals use light differently. Some can see ultraviolet. Some detect polarized light. Some glow in the dark. Fireflies use light to find mates. Deep-sea creatures emit light to lure prey. Plants grow toward light, phototropism seeking energy. Life on Earth has evolved around light. From the earliest photosynthetic cells to your own sleep cycles, light has shaped biology. And your body listens to it still. Blue light in the morning helps you wake. Red light at night helps you sleep. Your skin produces vitamin D when exposed to sunlight. Your brain adjusts its chemicals based on brightness. Even your mood shifts with the seasons, long days and short ones affecting your energy and clarity. Light doesn't just guide your vision, it guides your rhythms. Let's talk now about artificial light. Before electricity, humans lived by the sun. Work, rest, and travel were shaped by daylight. Candles and oil offered limited glow. Night was a boundary, but then came gas lamps, light bulbs, neon signs. Suddenly, the world lit up. We extended day into night. We lit streets, homes, and cities. We made light something we could control. That changed everything. Now night is optional. You can read, work, or scroll at any hour, but that comes with a cost. Excess light, light pollution dims the stars. In most cities, the Milky Way is invisible. The glow of human civilization washes out the ancient sky, and too much artificial light can confuse your body. It can disrupt sleep, strain eyes, and dull focus. We live in brightness, yet often forget what true darkness feels like. That's why moments like this, quiet, dim, focused, are rare and precious. Let's take another breath here. Remember a time when you stared at the stars, or watched sunlight dance on water, or followed a flashlight through the woods. Those memories are not just moments. They're recordings of light stored in your mind, tied to feelings, connected to places. Light enters your eyes, but it also enters your memory. You might remember the way morning sun filtered through curtains as a child, or the streetlights on a rainy night, or the flicker of a campfire on a friend's face. These are your personal constellations, not in the sky but in your mind. Light is the medium, meaning is what you make from it. And now, as you sit in this small pool of glow, perhaps from a lamp or a screen, you are surrounded again by light's quiet presence. It fills the room softly. It outlines your thoughts. It carries you into rest. And as you ease into sleep, know that light continues. Somewhere far from here, a star is shining. Its photons are leaving now, beginning a journey that may last billions of years. They may pass planets, nebulae, voids. Some will be lost. Some will be bent. And maybe someday one of them will find an eye. And that person will wonder too. The universe is vast, but light makes it visible. And though it cannot touch or speak, it tells everything. Imagine light not just as something that helps us see, but as something that connects you with the past, the present, and the possible. Every beam you catch with your eyes has a story, a path it's traveled, a source it left, a reason it arrived. Sometimes light is immediate, a glance from a friend, sunlight on your skin. Other times it's ancient, leaving a galaxy before Earth even formed, reaching us only now. And still, we treat it as familiar as though it's always been with us. But there are kinds of light we cannot see. The light your eyes detect is called visible light. It's just a tiny slice of the full electromagnetic spectrum. Beyond red is infrared, heat rays. Beyond blue is ultraviolet, energetic waves that can sunburn your skin. And farther still are microwaves, radio waves, X-rays, and gamma rays. These are all forms of light, waves of energy moving at the same speed, just in different sizes or wavelengths. Radio waves can be kilometers long. Gamma rays can be smaller than atoms, and each type interacts with the world differently. Radio waves carry music to your car. Microwaves cook your food. X-rays show your bones. Ultraviolet light reveals patterns in flowers that bees can see, but we can't. Infrared lets you see warmth, like the glow of a person in the dark. Light is a tool with many forms. Astronomers use this full range to study the universe. They build telescopes that see not just stars, but the heat around them, the particles they emit, the high-energy flares they burst with. Each type of light reveals a new layer of reality. A visible light telescope shows you the stars. A radio telescope shows you gas clouds and pulsars. An X-ray telescope reveals black hole jets and exploded stars. Each image is a translation, light turned into data, then color, then meaning. And all of it travels at the same speed, the speed of light, no matter its wavelength. This unity across such diversity is one of nature's quiet harmonies. But how does light move? Is it a wave or a particle? Strangely, it's both, a duality. This idea, wave-particle duality, means that light doesn't fit neatly into categories. When it moves through space, it spreads out like a wave. But when it strikes something, it hits like a particle, a single photon, and that photon carries energy. The shorter the wavelength, the more energy it has. Gamma rays are powerful. They can pass through flesh and damage cells. That's why radiation exposure can be harmful. Meanwhile, radio waves carry very little energy. They're safe, even in large amounts. Your eyes are tuned to a middle range, a sweet spot of energy and information. Enough to see colors, but not so much as to harm you. And that's not an accident. Life on Earth evolved under sunlight. Our atmosphere filters out most harmful rays, blocking X-rays and gamma rays, letting visible and some ultraviolet light through. Plants use this light for photosynthesis. Animals, including you, evolved eyes sensitive to it. Even now, your body responds to it. Morning light wakes you. Evening light slows you down. Your sleep cycle, your circadian rhythm, is guided by the color and intensity of light. Blue light in particular is a signal to your brain. Stay alert, stay awake. That's why screens can disrupt sleep. The blue light they emit tricks your body into thinking it's daytime. Dim warm light, like a candle or sunset, tells your brain it's time to rest. You're not just seeing light. You're responding to it, emotionally and physically. Even without noticing, you shift with the light around you. Now consider shadows. A shadow is a place where light doesn't reach, but more than that, it's a sign, an outline of an object's presence. Light can bend, scatter, reflect, but when it's blocked, a shadow forms. Shadows tell stories. They hint at shapes. They move with time. In the morning, your shadow stretches long. At noon, it shrinks. In the evening, it lengthens again. The position of the sun becomes a clock on the ground. Ancient people built sundials, shadows used to tell time. Long before mechanical clocks, light and shadow were how we tracked the day. And even now, shadows carry mood. A room with soft shadows feels calm. A scene with sharp shadows feels tense. Photographers and painters study them. Designers use them. Shadows shape our perception. They are the negative space of light, the places that remind us light isn't everywhere. And yet, even shadows are not fully dark. Some light bounces in, some filters through. True blackness is rare. Even in deep caves or sealed rooms, sensors can often still detect faint light. Only in outer space, far from any star, can you find near total darkness. But there, too, light travels. Cosmic rays, background radiation, faint glows from distant galaxies, all persist. The universe is never truly silent, never truly dark. Even the blackness between stars is filled with whispers. And now let's explore how fast light is. Because the speed of light isn't just a large number, it's a boundary. A fundamental rule of nature. You can't send information faster than light. No message, no signal, no ship. It defines the limits of cause and effect. If a star exploded 10 light-years away, you wouldn't know until 10 years later. Not because of delay in technology, but because the light takes that long to reach us. It's not just fast. It's as fast as anything can be. And because of that, time itself becomes relative. Move quickly, very quickly, and time slows down for you. That's not just theory, it's measured. Particles moving near light speed last longer than they would at rest. Their internal clocks slow down. Astronauts age slightly less than people on Earth. The faster you go, the more space and time stretch and warp, all to preserve the speed of light. This is the universe's way of keeping balance. It means that light isn't just something in the universe, it's woven into its structure. Distances are measured in light years. The space light covers in 1 year, roughly 10 trillion kilometers. That means when we say a galaxy is 50 million light years away, we're saying the light took 50 million years to reach us. You're not seeing that galaxy as it is. You're seeing it as it was. It may have changed, moved, even vanished, but its light remains, a fossil of what once existed. The night sky is a gallery of the past, and yet that past shapes the present. Stars born billions of years ago made the elements in your body. Carbon, oxygen, iron, all forged in stellar cores and scattered by explosions. You are, in a sense, stardust arranged by light. And now you sit in gentle light again, perhaps from a lamp or screen, carrying messages, forming images, connecting thoughts. Each photon that reaches you has traveled a tiny path, reflected, refracted, emitted. It began somewhere, maybe in a filament, maybe in a diode, and ended in your eye. The journey may be short, but the meaning it carries is vast. Light can be silent but never meaningless. Even now, the glow in your room is a signal. This moment, this story, this breath. And when you close your eyes, that light doesn't disappear. It fades, it lingers, it echoes. Behind your eyelids, your mind continues. Dreamlight forms, shapes, colors, movement born from memory and imagination. The brain doesn't stop painting with light. It just switches mediums. And when you sleep, your body recharges. Your cells repair. Your thoughts settle. And outside, light continues its quiet journey. Across streets and oceans. Through glass and trees, between stars. Always moving. Always reaching. Always arriving. Let's turn our attention to how light interacts with time in ways we can hardly believe. If you were able to chase a beam of light, getting closer and closer to its speed, time for you would slow down. From your point of view, your clock ticks normally. But to someone standing still, your time stretches. The faster you go, the slower you age compared to those not moving. This is not an idea from science fiction. It's a confirmed part of physics. We've tested it, observed it, and rely on it. Time stretches with speed. This is time dilation. And it's why light is so special. From a photon's perspective, no time passes between its creation and its end. It doesn't age. It doesn't experience a journey. It's born and arrives in a single moment. You, though, live deeply in time. You feel minutes, hours, and days. You remember the past and imagine the future. But for light, the universe is without delay. This contrast is profound. It makes us wonder what it means to travel across the cosmos, or through life itself. Now picture the surface of a lake just before sunrise. The air is still. Mist floats above the water. Then the first rays of sunlight stretch over the horizon, touching the mist and reflecting off the ripples. What you see is light, bouncing, scattering, changing direction, softening. Your eye receives that light and your brain builds a picture. But there's more. That beam of light began at the sun, traveled through space, passed through the atmosphere, bent slightly through particles of mist, and finally entered your eye. Every reflection, every shimmer on the water's surface tells a part of that journey. Light paints the scene, but only with your help. Your perception fills in the rest. This is how light becomes more than physics. It becomes beauty. It's in the golden glow of a candle in a quiet room, the subtle blue of the sky just before dusk, the glint in someone's eyes when they smile. These are not just wavelengths and angles. They are experiences shaped by emotion. Light becomes feeling. Even now, your surroundings are filled with it. It reflects off walls, furniture, pages, and screens. It creates contrast. It sets tone. A bright room energizes. A dim space calms. You can change your mood simply by shifting the light. Artists have known this for centuries. Painters study how light falls across skin. Photographers chase the golden hour. Architects design buildings to catch the morning sun. Filmmakers play with shadows to tell silent stories. And all of that is still just photons bouncing and arriving, but they carry meaning because you give it. Let's now look closer, deep into the nature of light's movement. Light doesn't need anything to travel through. Sound requires air or water or solid material, but light, it moves even in a perfect vacuum. In fact, it moves best there. Through the emptiness of space, light travels without hindrance, no resistance, no drag, no decay. That's why starlight can reach us from across the universe. There's nothing to slow it down. But in other materials, like water, glass, or even your own body, light's journey is more complex. It still travels at its constant speed between interactions. But in these materials, it gets absorbed and re-emitted by atoms. It pauses, continues, scatters, and bends. That's why light moves more slowly in water than in air. Not because the photon is slower, but because of all those interactions. This behavior lets us manipulate light. Lenses bend it to focus. Fiber optics guide it around corners. Filters allow only certain wavelengths through. We use mirrors to redirect it, polarizers to organize it, lasers to concentrate it. We've learned to shape light with precision, and we've used it to build. Lasers cut steel and heal eyes. Optical cables send internet around the world. Satellites bounce signals off Earth's surface. Cameras capture memories in frozen frames, and all of it relies on the same basic thing: light traveling from place to place. Let's step into the smallest spaces now, the realm of quantum mechanics. Here, light reveals even more strangeness. When a photon passes through a barrier with two slits, it doesn't simply choose one. If unobserved, it behaves like a wave, interfering with itself, as if it went through both at once. But if you observe which slit it chooses, the interference disappears. It acts like a particle. The pattern changes. This is the double-slit experiment, and it's one of the most puzzling discoveries in science. It suggests that the mere act of measuring light changes what it does, not because we disturb it, but because reality itself exists in multiple states until observed. This is where light blends into mystery. It seems to ask us, what is real? What is potential? What is certain? And yet, with all this strangeness, light is still our most trusted tool. It carries data from far galaxies, records images in cameras, scans barcodes, enables medical imaging, powers remote controls, and unlocks doors. It's in the code of your phone screen, the warmth of a sunbeam, the flash of a lighthouse guiding ships. Everywhere, light works silently. You barely think about it. You don't thank it when you read a book or notice a smile. But it's always there, weaving the world into something you can know. And it's always arriving. Every moment, new light finds you. Reflected off faces, walls, clouds, echoes of activity, whispers of events. Each second brings photons that began elsewhere, bounced, scattered, born, or broken free. And yet they all end here with you. Even now, as you absorb these words, light is doing the work. It carries symbols to your eyes, patterns to your brain, understanding to your thoughts. And when you rest and your eyes close, light is still there. Not entering, but remembered. Stored images replay, flashes of memory, drifts of dream. Your brain continues to weave with imagined light. And in that quiet world, time softens, thoughts stretch. You travel not through space, but through yourself. And somewhere beyond this room, a photon continues its journey. It left a star before humans existed. It crossed nebulae, passed through interstellar dust, slipped by comets. Now it moves on, perhaps toward someone else, or perhaps into the void. And that's light's story, always going, never stopping, never owned, just shared. Consider for a moment how light helps you remember. Not just events, but feelings. Light doesn't just show the world, it shapes how you recall it. The soft gold of late afternoon in your childhood, the flashing lights of a celebration, the dim blue of a sleepless night. Each one brings not just vision, but mood. Even memories are soaked in light. Your brain doesn't save just images. It remembers the lighting, the color, the tone, the intensity. You recall how it felt to be there, not just what was there. And that's how deeply light connects to who you are. It surrounds you so constantly that it often goes unnoticed. But remove it, and suddenly its absence is overwhelming. Imagine a cave far underground. No openings, no lamps, total darkness. You wave your hand in front of your face and see nothing, not even motion. Your eyes are open, but sight has stopped. In that darkness, even a match feels like sunrise. That shows how powerful light truly is. We often think of light as gentle, but it can be fierce. Blinding, burning, cutting. It can etch metal, ignite fire, or burst from a supernova with more energy than our sun will emit in its lifetime. So light isn't just delicate, it's powerful, and yet it travels without mass. A photon has no weight, no rest. It is always in motion. This strange property sets light apart from matter. It isn't made of atoms. It doesn't sit still. You can't hold it, but you can be warmed by it. You can't contain it, but you can guide it. We build tools, lenses, mirrors, prisms to shape light's path, but the light itself stays unchanged. It remains pure. Even after bouncing through 5 mirrors, bending through glass, reflecting off water, and passing into your eye, it's still just a photon, moving fast, delivering energy. Now let's talk about colors. When you see something red, it's because that object absorbs all other wavelengths of visible light and reflects red. When you see blue, the object bounces back only that wavelength. White reflects all. Black absorbs all. So color is not a property of the object itself. It's a result of how it interacts with light. And you, as the observer, complete that interaction. Your eyes have 3 types of color-detecting cells, cones tuned to red, green, and blue. Your brain mixes their signals to perceive the full spectrum. That means color is partly in your mind. It's not an illusion, but it is a construction. That's why lighting changes color. The same shirt looks different in sunlight versus fluorescent light. The light source changes what's reflected, and your brain adjusts what you see. This is called color constancy. Your brain tries to keep things looking consistent, even as the light shifts. It's also why shadows don't look completely black. You still perceive detail. Your mind fills in, and it's why artists study light so intensely, to mimic how it works in real life and how we perceive it. Shadows, highlights, reflections, they're tools not just of physics but of perception. Now think about a rainbow. It forms when light enters a droplet of water, bends, reflects off the back of the droplet, and exits again. Each color bends at a slightly different angle, spreading the light into a spectrum. But you only see a rainbow if you're at the right angle, looking away from the sun, with water droplets ahead of you. That means each person sees a different rainbow. It's not an object in the sky. It's a pattern created between light, water, and your eyes. So even the most beautiful things in nature are personal, made for your position, your moment. This isn't a metaphor, it's literal. Your rainbow is yours alone. Let's move to lightning. A flash of light across the sky, brief, powerful, terrifying, beautiful. Lightning is plasma, ionized air, superheated by an electrical discharge. It lights up the sky, branches out in forks, and then fades. But before it fades, it lights up everything. Trees, houses, clouds, even your face. That flash travels miles in an instant. And again, it moves faster than sound. That's why thunder comes later. The delay between flash and rumble tells you how far the lightning struck. Count the seconds, divide by 3, that's the distance in kilometers. Light becomes a ruler, a tool, and yet it feels magical. We use it to measure, but also to marvel. A lighthouse beacon, a comet's tail, a city skyline at night. These sights stir something in us, because they connect us to scale, to distance, to power, to vastness. Let's now explore how light is used to look inward. In medicine, light reveals what lies beneath skin and bone. X-rays show fractures. MRIs use magnetic fields and radio waves. CT scans build 3D images from slices of radiation. Ultrasounds bounce sound instead, but still rely on wave behavior much like light. We scan, we examine, we diagnose. We use light to save lives. In surgery, lasers make precise cuts. In cancer treatment, radiation targets tumors. In therapy, light treats depression and sleep disorders. We even study brain activity using infrared light, watching oxygen flow in real time. So the same light that lets you see stars also helps you heal. It reaches across space and inside your body. It's both cosmic and personal. Now think of communication. Fiber optic cables send light pulses across continents. Those pulses carry data, your voice, your text, your images. A conversation across oceans becomes possible because of light bouncing inside thin strands of glass. Satellites reflect and beam signals. Infrared remotes control TVs. Barcode scanners flash red beams. Light becomes language. It moves not just energy but meaning. And it does so at near-instant speeds. That's how we live now, wrapped in networks of invisible light. Wi-Fi, Bluetooth, cellular towers, all part of this web. Each moment you stream, call, or scroll, you're harnessing photons. And still, most of this goes unnoticed. You don't see the beam that connects your device to the tower. You don't feel the light that brings the page to your screen. But it's there, all around you. Even the night isn't truly dark. Streetlights, headlights, glowing signs, phone screens. We've filled the darkness with our own kind of stars. But in doing so, we've lost some things too. Light pollution blocks our view of the heavens. In many cities, the Milky Way is no longer visible. Children grow up never seeing the stars clearly. We've created a new kind of twilight, endless, artificial, constant. And while it brings safety, convenience, connection, it also brings fatigue, confusion, and distraction. Your body craves cycles, light and dark, day and night. When that balance is lost, so is your rhythm. That's why sleep experts suggest dimming screens at night, why natural light helps mood, why taking walks in daylight clears your thoughts. You are not separate from light. You are shaped by it. Your biology is tuned to the sun's rise and fall, your history marked by firelight and starlight. Your language filled with metaphors of brightness and shadow. You say things like a bright idea, a dark time, in the spotlight, a ray of hope. Light is how you understand even the intangible. And now, as you listen, you are surrounded again, by glow, by reflection, by warmth. Each surface catches and returns a little bit of the world, and you, quietly resting, are both observer and participant. Let's journey now into how light weaves into memory and language. Think of phrases you've heard, a bright future, out of the shadows, a glimmer of understanding. Light isn't just physical, it's symbolic. A stand-in for knowledge, truth, revelation. Darkness, in contrast, becomes mystery, fear, the unknown. You don't just walk into a room, you bring light into it. You don't just learn something, you shed light on it. This is how deeply light is tied to meaning. Even in stories, heroes carry torches, lanterns. They follow stars. They search for the light at the end of the tunnel, because light has always meant safety, a fire against the cold, a sunrise after danger, a candle guiding your way. From the beginning, humans have gathered around light, first flames, then bulbs, now screens. You live by it, you build with it, you think in it. And still, much of its nature remains a mystery. We can measure light's speed, but we don't fully understand what it is. A wave, a particle, a field, a packet of energy. We have equations, we have models, but the core of it, the what of light, is elusive. It behaves in ways that defy common sense. It acts like a particle in some experiments, like a wave in others. It can interfere with itself. It can be entangled, linked across space. When two particles of light are entangled, a change to one affects the other instantly, no matter the distance. This is quantum entanglement, and it seems to defy the limit of light speed. We don't yet know how this works, but we know it does. So light, while measurable, remains mysterious. It is a boundary and a bridge, a constant and a question. Now imagine standing outside at night. The stars are scattered across the sky, some faint, some sharp. A planet glows near the horizon. Maybe the moon hangs low. All that light, every speck, traveled vast distances. And now it touches your eye. It ends with you. You are the surface it reaches. And that's a powerful thought. You often think of yourself as small. But light sees you as a destination, a goal, a point of arrival. You who sleep, who dream, who wonder. You receive light from stars you'll never visit. You walk in the photons of a universe older than memory. And still, you continue. You reflect light too. You shine it on others, in gestures, in words, in presence. You create moments of brightness, not just with lamps or phones, but with being. Now consider the flicker of firelight. Its motion is chaotic. No two flames dance the same. But the glow they cast feels ancient, comforting. Your ancestors stared into fire for warmth, for safety, for story. They saw light not as utility, but as spirit. Even today, a fireplace draws people in. Candles make a room softer. Lanterns make the dark less lonely. Light pulls you toward it, it suggests life. That's why cities glow, why windows gleam, why stars captivate. In all that space and time, light means something is happening, something is present. Let's move now to how light affects time in our minds. Think of how quickly a flash happens, a camera strobe, a lightning bolt, a reflection off a mirror. Each lasts less than a second, but in memory it can stretch. Trauma, surprise, awe, these moments feel long even if they're brief. That's not light stretching time, it's your brain responding, but it shows how light marks events. A wedding photo, a candle blown out, a first glimpse of something wonderful. Light captures the turning points, and in those moments time bends. You hold them longer than they lasted. Now let's consider the northern lights. Aurora borealis, waves of green, red, purple dancing across polar skies. They're caused by particles from the sun striking Earth's atmosphere. The energy excites atoms, which then release light. It's cosmic interaction turned into beauty, and it's fleeting. You can't predict exactly how strong the lights will be or when. You wait, you watch, and when they come, you're silent, because it feels like the sky is speaking. It's not just science, it's ceremony. Like lightning, auroras are nature's performance. Unexpected, uncontrolled, alive. Let's now explore bioluminescence. Some living things produce light: fireflies, certain fungi, deep-sea creatures. They create light through chemical reactions. No heat, no flame, just glow. A jellyfish pulsing blue, an anglerfish's lure, plankton lighting up the waves behind a boat. This is life borrowing light not from the sun but from inside. And in the dark places of the world, deep oceans, caves, forest floors, this glow becomes guidance. It says, I'm here, I'm alive. Now consider sleep. When you close your eyes, you shut out light. You signal your body to rest. Your brain releases melatonin, a hormone that promotes sleep, and it does so based on darkness. That's why bright screens at night disrupt your rhythms. You're meant to sleep when the light fades. Your inner clock, the circadian rhythm, follows the day. Light in the morning resets it. Darkness at night prepares it. Even blind individuals without visual input can sometimes detect light for timing. That's how fundamental it is. Your body doesn't just see light, it needs it, and it listens to it every day. Now reflect on how light ends its journey. A photon may bounce, scatter, reflect, but eventually it's absorbed. Its energy is transferred into heat, into chemical reaction, into sight. Nothing is wasted. And in that final moment, the photon's life is complete. Its path, its speed, its purpose, all fulfilled. It began somewhere. It moved freely. It arrived. And then it vanished, but not into nothing. It became something else. And that is the cycle. Light is not eternal, but its effects are. From stars to fields to your own body, light touches, changes, and moves on. It is both traveler and messenger. Silent but full of meaning. Let's follow light as it continues its quiet journey, slipping through every crack in the world. It reaches into the smallest corners, under leaves, through curtains, around eyelids. No matter how tightly you try to block it, light finds a way in. It's gentle but insistent. It doesn't force its way. It simply moves forward always until it's absorbed or turned. Even when you're not paying attention, it's painting your world. It reveals texture, rugged bark, smooth glass, the folds in fabric. Without light, those details disappear. That means light gives shape to what exists. Not just outlines, but character. You know what something feels like just by how it catches the light. A glossy book cover, a matte wall, a polished stone. You sense depth, direction, weight, all through reflections. Now consider how light connects moments. The glow from a street lamp seen through rain, the flicker of a flame before sleep, the flickering television screen in a darkened room. These moments stick. They attach to emotion. Because light carries atmosphere. A single bulb can feel lonely. A string of lights can feel festive. Candlelight can feel romantic or reverent. The source changes everything. That's why lighting is so crucial in storytelling. Movies, plays, even novels use light to set mood. A hallway bathed in red, a forest under moonlight, a window catching the last orange of sunset. Your mind fills in the rest. Light becomes memory, and memory becomes story. Let's talk about how light bends. When light moves from one material to another, like from air to water, it changes speed. That shift causes it to bend. This is refraction. You've seen it when a straw looks broken in a glass, when a fish appears closer than it is, when the sun seems to flatten near the horizon. This bending lets us build lenses. A lens focuses light. It can make things look bigger, smaller, closer, farther. That's how glasses correct vision. If your eye doesn't focus light properly, a lens adjusts it. The world becomes clear again. Cameras use the same idea. So do microscopes and telescopes. A lens brings distant or tiny things into focus. But always it's light doing the work. A telescope doesn't just magnify, it gathers more light. That's why larger telescopes can see fainter stars. They drink more starlight. And with enough lenses, mirrors, and precision, we can see galaxies that formed when the universe was young. All through the journey of photons, tiny messengers from long ago. Let's move to light's role in photography. A photograph isn't just a picture, it's a captured pattern of light. In film cameras, light hits chemicals that react and form an image. In digital cameras, light hits sensors that convert it into data. Either way, the light creates a record. It's not just what was there, but what was seen. A photo isn't objective. It depends on exposure, angle, timing. It tells a story filtered through decisions. And once printed or displayed, it becomes a light source again, bouncing photons to new eyes. So a single ray of light can inspire a cycle that lasts generations. Let's consider how animals use light. Some creatures have vision beyond what we see. Bees can detect ultraviolet patterns in flowers. Snakes sense infrared heat. Birds navigate using the polarization of sunlight. Light is not just illumination, it's communication. Mimicry, camouflage, attraction, all depend on how creatures reflect or produce light. Think of a peacock's feathers, a squid's shifting patterns, a chameleon's slow color change. These are all ways to speak without words, using light as language. Even plants respond to it. They turn toward the sun. They adjust growth based on intensity and duration. They know when to bloom, when to sleep, when to reach. All by following light. It's the silent conductor of life. Now imagine light slowed. In certain materials, scientists have managed to slow light almost to a stop, not by breaking its speed, but by creating conditions that delay its movement through interactions. This lets researchers explore the limits of physics, because if you can slow light, maybe you can store it, or guide it in new ways. This might lead to better computers, more precise sensors, new kinds of communication. Light is not just fast, it's flexible. It adapts to context. Let's reflect on mirrors. When you look into one, you see yourself, reversed, framed, real and unreal. A mirror doesn't just bounce light, it preserves detail. It returns photons in patterns your eyes recognize. You trust mirrors, but sometimes they deceive. Funhouse mirrors stretch you. Curved mirrors shrink or double. Even a flat mirror limits what you see. You see only the angles that bounce back. You can't look into your own eyes directly. You see a version always slightly separate. That creates distance even in closeness. Light reflects, but it doesn't lie. It only follows paths. And in doing so, it shows you the boundaries of perspective. Let's now consider illusions. Optical illusions work because light tricks your brain, not by changing but by presenting patterns that confuse perception. Lines that seem to bend, colors that appear different depending on their neighbors, motion where there is none. These illusions reveal how your mind builds reality, not just from input but from expectation. You don't see everything. You interpret what you see. Light gives you information. Your brain gives it meaning. Now let's revisit time. Light allows us to look into the past, but it may also let us measure the future. Atomic clocks use the vibrations of atoms, stimulated by light, to keep time with stunning precision. GPS satellites rely on this timing. So do financial systems, scientific research, internet protocols. Without light, timekeeping would be less accurate, less stable. So photons help you navigate space and manage time. They are the quiet keepers of order. Finally, let's turn inward again. What light means to you personally. Think of a time you were comforted by a lamp in the dark, or a flashlight under covers, or headlights on a long road home. These lights did more than show, they soothed. They told you you are not alone, that someone lit the path, that the world continues, that warmth is nearby. So as you sit or lie or rest, remember that you are in light's care. It surrounds you not just with vision but with connection. Even now these words reach you because of light, carried on waves, converted into images, reflected from screen to eye to mind. And in that path, something silent becomes something shared. Let's return to the idea of connection, how light binds us to one another, even across distance. A candle in a window can signal hope. A lighthouse beam can guide a ship through fog. A porch light can mean someone is waiting. These aren't just practical signals. They're emotional ones. You don't just follow light, you feel it. That's why festivals often center around it. Lanterns in the night sky, bonfires in winter, fireworks in summer, strings of lights wrapped around trees. These traditions exist around the world in every culture, in every era. Because when darkness stretches, humans light things up. It's instinctual, it's symbolic. It says, we are here, we are alive, we remember, we celebrate, we continue. Let's now think about how you use light every day without noticing. You flip a switch and a room glows. You check a screen and the day's schedule appears. You take a photo, glance at a sign, read a label. Each of these depends on light. And yet, you rarely think about the photons bouncing around you. They're invisible unless they strike something. You never see the beam itself, only the spot it touches. Even a laser so narrow and focused is only visible because particles in the air scatter it. Light reveals other things, but hides its own path. This is humbling. You live by something you can't grasp. You rely on it, depend on it, even shape it, but it remains intangible. A whisper from the universe, always speaking, never seen directly. And still, we've harnessed it. Solar panels turn light into electricity. Light sensors automate doors, lights, and alarms. Ultraviolet light sterilizes tools. Infrared cameras see through smoke. We've built machines that see differently than we do, expanding light's use beyond human vision. Because visible light is only a tiny slice of the electromagnetic spectrum. Below it, radio waves, microwaves, infrared. Above it, ultraviolet, X-rays, gamma rays. All of these are forms of light, just with different frequencies. The difference between a radio signal and a beam of blue light, just the wavelength. That's it. It's all part of the same family. So light isn't just what you see. It's what you use to cook food, send messages, diagnose illness, explore space. It's everywhere in everything. Let's now visit distant galaxies. When astronomers look deep into space, they look back in time. Light from distant galaxies began its journey billions of years ago. It traveled, unimpeded, across cosmic distances, only now arriving at Earth. We see those galaxies not as they are, but as they were. A galaxy 1 billion light-years away appears as it was a billion years ago. So telescopes aren't just instruments. They're time machines. They let us watch the history of the universe unfold. The first stars, the earliest structures, the aftermath of explosions that happened before Earth even formed. And all of it, every discovery, every image, comes from light. Light is the storyteller of the cosmos. It carries tales across time and space. Now consider the cosmic microwave background. This faint glow fills the universe. It's the leftover radiation from the Big Bang, stretched into microwaves by billions of years of expansion. It's the oldest light we can detect, and it tells us about the universe's birth, its shape, its fate. It's the echo of everything beginning, and we found it by listening, not with ears, but with detectors sensitive to that ancient light. So even silence holds messages, if you know how to listen. Now let's think about silence and stillness in your own life. Moments where the light is dim, the noise fades, and time slows. These are moments of reflection, literal and emotional. A quiet room with a candle, a walk under moonlight, a deep breath beside a window. In those moments, light isn't just illumination. It's atmosphere. It shapes your inner world. You think differently in soft light than in harsh. You dream more easily in the dark. Light guides your thoughts as much as your vision. That's why you dim lights before bed. Why sunrise feels hopeful. Why the golden hour makes everything seem gentle. Light changes you, not just physically, but emotionally. Let's talk about speed again. Light moves fast, 299,792 kilometers per second in a vacuum. It's so fast it circles the Earth 7 times in 1 second. Yet for all its speed, it still takes time to arrive. Sunlight takes 8 minutes to reach Earth. Moonlight, about 1.5 seconds. A message to Mars takes several minutes. So even light has limits, and those limits define your experience. You can't see things as they are. You only see them as they were. Every glance is a glimpse of the past. Even the face in the mirror is slightly delayed. This is subtle, but it reminds us there is no now that we all share. There's only what we receive when we receive it, and light delivers that reality. Let's now pause. Let the idea settle. You are surrounded by light, moving, bouncing, arriving, always. Every moment is shaped by it, colored by it, directed by it. And yet it's silent, weightless, invisible until it touches something. You can block it with a hand, redirect it with a mirror, focus it with a lens, but you cannot hold it. You can only witness it, and that's enough. Because witnessing light is how you understand the world and your place within it. Let's now wander into the subtle ways light sculpts your world. Think of the shifting colors in a day. Morning's gold, noon's harsh white, evening's soft orange, twilight's blue. These changes aren't just artistic, they're scientific. As the sun moves, its angle through the atmosphere shifts. Shorter blue wavelengths scatter first, which is why the sky is blue during the day. As the sun sinks, its light travels through more atmosphere, more scattering. leaving reds and oranges to dominate. This shift isn't random, it's predictable, measured, understood. And yet it still feels like magic. That's the duality of light. It's mathematics and emotion. It's angle and awe. Now picture being underwater. Sunlight filters down in shafts. Deeper you go, less light makes it. Reds disappear first, then oranges, then yellows. Everything starts to turn blue, then green, then dark. This isn't a trick, it's physics. Water absorbs light unevenly. Long wavelengths fade fast. Shorter ones persist. That's why deep-sea creatures often glow in blue. They live where only blue light survives. And that's also why, when you swim near the surface, everything feels dreamlike. Ripples distort shadows. Light dances across skin. The world feels slower, softer. Because light is slower in water, not in speed between interactions, but in the way it navigates the maze of molecules. That's how you get refraction, bending, distortion. It's not light failing, it's light adapting. Let's talk now about shadow, not just darkness, but the edge of light. A shadow isn't absence. It's the shape of light's journey interrupted. You see the form of what blocked it. A hand's silhouette on a wall, a tree's lace across pavement, the outline of leaves fluttering against your window. Shadow shows shape. It adds texture. It tells you about distance, direction, time. In ancient days, people told time with shadows. Sundials, obelisks. The length and tilt of a shadow marked the hour. And still today, you read shadows unconsciously. You know the time of day, the weather, the mood, just by the shade on the floor. Even your face is understood in light and shadow. A nose, a cheekbone, a brow sculpted by where the light falls. Artists learn this early. Not to draw the thing, but the shadow it casts. Because the shadow tells you what's real. Let's reflect again on reflection. When light bounces, it changes direction. But sometimes it also changes meaning. A mirror reflects what is, but a puddle reflects what might be. Clouds upside down, trees shimmering, a sky on the ground. Reflection turns the world into poetry. And sometimes it turns the ordinary into the extraordinary. A sunset caught in a window, a face lit from below, the glow of headlights on wet asphalt. These are fleeting scenes, gone in seconds, but powerful because they remind you light doesn't just reveal, it reimagines. Now consider glimmer, not a steady beam but a flicker, a sparkle, a pulse, fireflies, stars, streetlights through tears. These glimmers mean something. They catch your eye. They feel alive. A steady light may be useful, but a flicker draws attention. Why? Because change signals life. Movement signals presence. That's why candles feel alive. Why a campfire soothes. Why the northern lights mesmerize. They shift. And in that shifting, you find meaning. Now let's talk lenses again, not the kind in your eye or camera, but in nature. The atmosphere is a giant lens. It bends starlight, refracts the sun, shifts the moon's position. Sometimes it creates mirages, a puddle on the road that isn't there, a ship that floats, a mountain that stretches. These aren't hallucinations, they're light redirected. Your eyes see what light brings. And when light is bent, so is perception. That's humbling, because it means your experience of reality is filtered, not just by biology but by physics. You live in a version of the world shaped by light's journey, not the thing itself, but the thing revealed. Let's pause here. Think of the last time light surprised you. A shaft through clouds, a rainbow on a wall, a sudden glint off a ring. That moment of beauty wasn't planned. It happened because light, freely moving, struck just the right surface at just the right angle in just the right instant. And you were there to notice, to witness. That's all light asks. Let's shift gently into how light shapes your sense of space. Imagine a room lit only by candles. Corners melt into shadow. Walls feel closer. Edges blur. Now imagine the same room lit by bright fluorescence. Every object becomes sharp. The room feels wider, flatter, clearer. The layout didn't change, but your perception did, because light defines space. It tells you where something begins and ends, where it sits in relation to you. Whether it's near or far, solid or soft, open or closed. Without it, space collapses into nothingness. Now think of fog. Fog doesn't block light, it scatters it. That's why headlights glow instead of beam, why shadows vanish, why everything seems to float. In fog, light loses direction, and so do you. But again, this isn't failure, it's variation. It's a new way to see the same world. Sometimes seeing less reveals more. Now picture a tunnel of trees, branches overhead, light filtering through the leaves. This dappled light is not uniform, it's speckled. Moving, alive, it creates rhythm, mood, a sense of mystery. Dappled light feels different than full sunlight. It feels quieter, older, softer. It's nature's version of stained glass, and it reminds you light doesn't have to be strong to be powerful. Let's talk about the edge of light, that moment just before sunrise, just after sunset, where the sky holds both day and night. This is the liminal space between dark and light, asleep and awake. Twilight, the world hushes, colors deepen, shadows stretch, and for a brief moment time feels slower. Because twilight is not one thing or another, it's the in-between. And in that transition you feel change, not abrupt, not loud, but gentle, inevitable. Now let's return to firelight. A campfire doesn't light evenly, it flickers, dances, hides and reveals. And in that movement stories are told. Firelight is ancient, shared, intimate. It gathers people around, it draws faces from darkness. It makes eyes glow and skin shimmer. Even today, in a world of electric light, fire holds power. It feels alive because it is. It consumes, it warms, it moves. And light born of flame carries history. Let's consider reflections again, not just visual but emotional. The way moonlight on water stirs something inside. The way sunlight through dust makes you pause. The way shadows lengthen before rain. These are subtle cues, but they shape your state of mind. They guide memory. They create mood. A reflection on glass. A silhouette behind curtains. A face lit by passing headlights. These become moments you remember not for what they were but for how they felt. Because light is feeling, not always loud, not always bright. Sometimes it's just enough. Let's pause on color once more. Color isn't in the object, it's in the interaction. A red apple under blue light may look black. A white shirt in a sunset turns orange. The same sky shifts from pale to violet in minutes. Color moves with time, it's not fixed, and that makes it magical. You don't see things, you see light bouncing from them. Color is light, bent and returned. And the brain builds beauty from that. You walk through a world painted by reflection. Now think of how you describe emotion. You feel bright. You feel low. You see light at the end of the tunnel. You feel like a shadow. These aren't metaphors by accident. They're rooted in experience. You associate clarity with light, obscurity with dark, joy with glow, grief with dimness. Even memory uses these cues, a bright memory, a faded one. Light becomes language. Let's consider how we display emotion in space. A well-lit home feels open. A dim restaurant feels private. A stage spotlight isolates. A disco strobe excites. Designers, directors, even architects use light to shape feeling. It's invisible control, and it works, because you are wired for light. Your rhythms, your hormones, your focus all shift with brightness. Too little light and you drift. Too much and you tense. Balanced light calms. Natural light centers. Warm light comforts. These are not opinions, they're biological facts. You evolved under the sky. Let's now imagine being in complete darkness. Total black. No shapes. No shadows. No flicker. You blink but nothing changes. You reach out but there's no feedback. This darkness isn't just visual, it's disorienting. Because your brain expects light. And when it's gone, your other senses surge. You listen harder, feel more, breathe deeper. And still your mind paints images, shapes from memory, color from thought. You can't stop seeing. Even without light, you dream. And those dreams are full of brightness. Let's now walk into dreams themselves. The dreams you recall often have scenes, rooms, skies, paths, people, and those scenes are lit. Sometimes clearly, sometimes dimly, sometimes with colors that don't exist in waking life. But always light plays a role. Your subconscious uses it too, to reveal, to hide, to build story. So even in your sleep, light remains your guide. Not from outside, but from within. Let's gently shift now into how light connects the everyday to the cosmic. The screen you're looking at right now, its glow travels just inches, but the light from a distant star, that has crossed millions of years just to meet your gaze. And yet, both photons, one from your screen, one from a galaxy, travel the same speed. That sameness is extraordinary. Whether born from an LED or a supernova, light obeys the same rules. It's consistent, universal. It reminds you that the laws of physics are shared, that you and the stars are bound by the same fabric. That light links you not only to the moment, but to the entire timeline of existence. Let's revisit lenses once more, specifically the eye. Your eyes are organs made to gather light. The lens inside bends it, the retina collects it, and millions of photoreceptors translate it into signals. You don't see with your eyes alone. You see with your brain interpreting what your eyes receive. And yet this whole system is based on light. When babies are born, they learn to see. It takes time for their brains to learn how to use the light coming in. Patterns, depth, edges, these aren't automatic. They're constructed. You're not just receiving light, you're learning how to read it every day. That's why a change in lighting changes how you feel in a space. It's not imagination, it's perception shifting, because light is information, and your brain responds. Let's return to stars. Each star you see is a point of light, tiny, steady, distant. But through a telescope, that point becomes a disk, a surface, a world of its own. That dot you saw was not small, it was far. Distance shrinks things, but light brings them close. It's how you learn what's out there. You see a star's color, brightness, even what it's made of, by analyzing its light. Spectroscopy breaks down starlight into lines and bands. These reveal elements, hydrogen, helium, carbon. So from trillions of kilometers away, light lets you know what burns. That's profound. Now consider exoplanets. We rarely see them directly. Instead, we detect them by how they affect starlight. A slight dimming as they pass in front, a wobble in the star's position, a faint shift in color. Light lets us sense planets we cannot see, and in those patterns we infer atmospheres, temperatures, even possibilities for life. So again, light is not just a beam, it's a messenger, carrying more than shape, carrying story. Let's move now to the concept of color again, but not as appearance, as temperature. Stars have color based on how hot they are. Cooler stars shine red. Warmer stars burn white or blue. This isn't aesthetic, it's physics. Color tells you temperature. This is true beyond stars. A hot metal glows red, then orange, then white. A hotter flame turns blue. So when you see color, you're seeing energy. Even without touching, light tells you about heat. That's powerful. Let's now look inward again to thought. When you close your eyes and picture something, an image, a place, a memory, what lights that vision? There's no real light inside your mind. And yet you see. You imagine brightness, contrast, hue. That's your brain recreating light from memory. It uses stored patterns of how light interacts with the world to build internal scenes. So light lives not only outside you, but within. You carry it always, even in silence, even in sleep. Let's speak again of sleep. Most people sleep best in darkness because light signals wakefulness. Your body reads it as day, but there are exceptions. Some find comfort in a soft glow, a nightlight, a hallway bulb, a crack under the door. Not for vision, but for presence. The light says, all is well, it's a symbol of safety. And sometimes that's all you need. Not full brightness, just a whisper. Let's visit once more the sky. The moon does not make its own light. It reflects sunlight, always has, but its glow shapes your nights. A full moon can light a field. A crescent can shift the tide, and culturally the moon has always mattered. Calendars, rituals, rhythms. Because of its light, borrowed but consistent. It's a reminder that reflected light is still real, still useful, still beautiful. The same is true of people. You don't have to shine on your own. Sometimes reflecting light is enough. Now let's return to the concept of invisibility, not in fiction but in fact. Most of the light in the universe is invisible to your eyes. You see only a narrow band, from violet to red. Outside that, there's infrared, ultraviolet, X-rays, gamma rays, radio waves, microwaves. All are light, all are real. You just can't see them unaided. But technology extends your senses. Infrared cameras show heat. X-ray machines reveal bones. Radio telescopes detect whispers from space. So even though you see only a sliver, you live in a world bathed in invisible light. You're surrounded by signals, pulses, echoes, passing through you, unnoticed. And yet they shape your reality. Wi-Fi, cell phones, satellite transmissions. These rely on light outside the visible. They feel like magic. But they are photons too. That's humbling. To know that you walk through oceans of light, most of which you'll never see. Let's revisit time one more time. Light not only lets us measure it, it defines it. In the theory of relativity, time and space are linked, and the speed of light is the cosmic speed limit. No signal can move faster. That means everything, every cause and effect, is filtered through light's pace. In extreme cases, this has strange effects. Near a black hole, gravity bends light so much that time appears to slow. To a distant observer, a clock near the event horizon ticks slower. This is an illusion, it's measurable. Light obeys the shape of space, and space bends near mass. So black holes don't just trap light, they reshape time. And light reveals that. Again, it's light telling the story. Let's go even deeper. When light passes through a gravitational field, it bends. This is called gravitational lensing. Massive galaxies can bend the light from even more distant objects behind them. And this creates arcs, rings, or even multiple images. It's nature's own telescope, and it lets us study things too faint to see directly. This is how we found some of the most distant galaxies, by watching how their light bends. It's light revealing not just the object, but the path. And the path tells us about gravity, mass, structure. Let's shift again. Imagine being on a spaceship, moving near the speed of light. Relativity tells us that time for you would pass more slowly than for someone at rest. If you traveled far and returned, less time would have passed for you. This isn't science fiction, it's science. It's been tested with particles in accelerators, with satellites and atomic clocks. Time dilation is real, and light explains it, because the speed of light is constant. To keep that speed steady, time and space must adjust. That's the foundation of modern physics. Light isn't just illumination. It's the thread that holds reality together. Now think of the quiet light, starlight on a still night, a flashlight on a trail, a hallway bulb at 2 a.m. These aren't bright, but they matter. They guide gently. They remind you that even small light can be enough. You don't need brilliance to see. You don't need noise to understand. You just need presence. That's what soft light teaches. Let's now imagine a room with no windows, no lights, no screens, total dark. But then a single match is struck. The whole room changes, not in brightness, but in feel. That tiny flame shifts the space from unknown to known, from empty to present. That's the power of even the smallest light. It alters perception, emotion, experience. Light creates place. Let's pause again. Let these ideas settle. You are not just a viewer of light, you are a participant. You reflect it, absorb it, emit it in tiny ways. You build your sense of self through how light interacts with you. Photos, memories, mirrors, all require light. Your very identity is lit. And the stories you tell, the ones you remember, the ones you dream, are painted in light. Even now, as you listen, you are surrounded by it. Maybe from a lamp, a screen, a moon outside. Whatever the source, it's here. It's wrapping around you, carrying these words, holding this moment. Light doesn't ask for attention. It just shows up, and in doing so, it gives everything else meaning. Let's draw this gentle journey to a close, not with a grand conclusion, but with a quiet return. We began with speed, with the impossible swiftness of light, with photons that race through space and time, touching everything, never slowing, never aging. And now we end with stillness, because even in their motion, light brings calm. It offers clarity, reflection, connection. It doesn't rush you, it reveals. Every corner of your life is shaped by light. The way you wake, the way you rest, the colors you see, the stories you hold, even your dreams are built with its echoes. And so this story too has moved like light, traveling outward from idea to voice to you. You've followed it gently, patiently, curiously, like stargazing, like candlelight, like sunlight on skin. Each moment shaped not by loudness but by quiet presence, because light doesn't demand, it offers. It's always there, waiting. Now think one last time of the photons arriving at your eyes this very instant. Some left their sources moments ago, some years, some longer than Earth has existed, and yet they've arrived without expectation. They didn't ask to be noticed, but by seeing them you complete the journey. Because light needs only one thing to be real, a witness. And tonight that witness is you, so rest now in that awareness. You are part of a vast, glowing universe, not separate from it but bathed in it, carried by it, lit by it. And with that we gently end this exploration, not with a bang but with a beam. A soft, steady reminder, the light is always there. Even when you close your eyes, even when you sleep, it will still be waiting just like now, quiet, gentle, and always here.